This is Lesson 1.2, Integers. This serves as a quick review of all the operations of integers you may have learned in previous courses. This lesson is divided up into three parts. Part A is adding integers, B subtracting integers, and C is multiplying and dividing integers. So the essential question that you need to ask yourself when you're done with this list, how do I perform calculations if there are negative numbers? And by the end of the lesson, you should be able to identify the definition of an integer, properly read integer problems, model the sum of integers with what's called the additive inverse property of 0. You need to be able to list the rules of adding integers, and therefore then also using those rules to add integers, subtract integers, quickly recognize addition versus subtraction problems, and multiply and divide integers. Now the reason why we spend so much time learning about integers is in the previous lesson you learned that coefficients and constants. Let's take a look at a problem real quick. Coefficients, those are the numbers with variables, and constants, the numbers that are not with our variables, have signs to them, either positive or negative. That makes them integers. And we're going to be doing something with those coefficients and constants in the upcoming lessons. So we need to know how to add, subtract, multiply, and divide them. The definition of integers is all real numbers and their opposites, or negative numbers. If on a test you would have a definition of integers, look for that and negative numbers. Some examples of integers are positive 2, negative 1/2, positive 0.5. So the integers can be fractions and decimals, just they have those signs to them, positive or negative. Some important facts you need to remember about integers. Signs are either positive or negative, always come before the number, never after. So when you read an integer, it's -4, not 4 negative. Numbers have two signs. The first positive or negative symbol means the operation. I'm sorry, let me say that again. What I was trying to say is numbers never have two signs. The first positive or negative symbol means the operation, plus or minus. So here in this example, you would read this as -3 minus -7. So that symbol right here, just a second, let me get to it. Right there means the minus, because you should never have two negative signs side by side. All numbers, or as we work in algebra, coefficients and constants, have a sign of positive or negative. If you don't see it, its sign is, if you don't see it, you assume that it's positive. So here's the example that 5 plus -2 could be read as positive 5 plus -2. So let's make sure you understand what we're trying to say here. I want you to write out these problems, just the mathematical phrase of what you see there, in words. So go ahead and push pause if you need to for a second and write down the answer for number 1, and then press play to check. Okay, your first answer should read +1 plus -4. Oops. Look at the next one. Careful, this is a little tricky. Don't forget that you have to have an operation in there. When you're ready, push play again. Let's see, did you write -7 minus +3? Notice that 3 did not have a sign to it. We saw that you wouldn't write -7, -3, because then you're missing its operation. You need an operation in there, either plus or minus. Okay, so that would have been a +3. This is going to be pretty important when you get into subtracting integers here in a minute. The last one is just an example of, yes, problems don't always have to be written horizontally, they can be written vertically. So how would you write this one? Go ahead and write your answer down, and then push play when you're ready to check. Alright, you should have written -5 plus -4. Alright, your first operation is adding integers, and I would like for you to write in your notes the word combine. We're going to use that word in the future, combining, and whenever you see the word combine, that means the same thing as adding, so using the adding rules. One of the properties that is helpful to know is that whenever you add the opposite of any number, it will always equal to 0. For example, if someone owed you $2 and they paid you back $2, then they would owe you no money, 0. So 1 plus -1 is also equal to 0. It doesn't matter what the numbers are. If it's the same number but opposite signs, they always equal 0. You can use the additive inverse property of 0 to help add integers by drawing a picture. So here we have a picture below of 4 plus -6. So I've drawn for you 4 plus signs to represent the 4 positives, and 6 negative signs to equal the -6. The circles represent what we call 0 pairs. We have pairs of positive and negative symbols. There are 4 0 pairs. Notice we have 2 negatives right here left over. Those 2 negatives represent our answer because this equals 0, that equals 0, that equals 0, 0. So we're left with 2 negatives. So the answer to 4 plus -6 equals +2. All right. So whenever you have the same number at opposite signs, it's called a 0 pair. You're using that additive inverse property. Let's use the symbols of positive and negatives to answer the next 2 questions. In example 1, you have -3 plus 8. So let's write this out with symbols. -3 would be 1, 2, 3 negatives, and 8 positives. 1, 2, 3, 4, 5, 6, 7, 8. To figure out our answer, we need to first find our 0 pairs. Well, we got 1 pair of zeros, 2, 3 pair of zeros. What's left over? Well, I see 5 positives. So the answer to number 1 is +5. Try it for example 2. We have 3 negatives, 1, 2, 3, plus 8 negatives. 1, 2, 3, 4, 5, 6, 7, 8. Our next task is to circle our 0 pairs. Be careful, don't be doing this. Those aren't 0 pairs, they're both negatives. You need a positive and a negative to make a 0 pair. Because we have no 0 pairs, what do we have left over? Well, we have 8, 9, 10, 11 negative signs. So our answer is -11. Alright, take a look at guided practice set A, and I want you to apply this the property of 0 to solve these 8 problems. If you happen to notice any 0 pairs right off the bat, put a star next to it and answer it with 0. You need to start recognizing 0 pairs. Remember, this is only when you're combining or adding 2 numbers where the signs are opposite do we say that the answer is equal to 0 or a 0 pair. Alright, you might think that there's a lot of drawing here with the negative signs and positive signs, but this will really help you understand the rules that we're going to use here in a minute to solve addition of integer problems. So I want you to look for a pattern as you're doing these. But please, for right now, do use the positive and negative signs to solve each problem, even if you may know the rules to adding additions from maybe a previous class. Go ahead and try it now so that you remind yourself of this pattern. When you're ready to check your answers, then push play. Okay, are you ready to check your answer? In the first problem, you had 7 negatives and 2 positives, which created 2 sets of 0 pairs, and you had 5 negatives left over, so your answer should be -5. In the second problem, you had 2 negatives and 4 negatives that you were combining together, and you didn't have any 0 pairs, so altogether you had 6 negatives, or -6. In the third problem, you had a -8 and a +8. That's a 0 pair. So you didn't really need to draw your symbols. You knew right off the bat that that equals 0. In problem number 4, you had 5 positives and 7 negatives. And after you made your 0 pairs, then you had 2 negatives left over. In problem number 5, you had 9 positives and 3 positives. You didn't have any 0 pairs, so altogether you had 12 positives, or positive 12 was your final answer. In problem 6, you had 2 positives and 7 negatives. You found a couple 0 pairs, and that left you with 5 negatives left over. Compare that problem, problem 6, to problem number 1. Look, we just flipped them around. The 7 was still negative, the 2 was still positive. We still got -5 no matter which way we wrote it. Look at number 7. You had 2 negatives and 9 positives. Which meant you had a couple of 0 pairs, and it looks like you had 7 positives left over. So your answer was +7. And in problem number 8, you had 9 positives and 3 positives that you were combining with. You had no 0 pairs, so your answer was +12. Problem number 5 and number 8 was the exact same problem. I didn't really mean to do that, but oh well, we already answered it there. So I want to know, do you discover any pattern there? Look at the problems that maybe had both negative signs, like problem number 2, and compare that to like problem number 5 and problem number 8. What do you notice that's the same on problem number 2, 5, and 8? How about that their signs are the same? In problem number 2, the signs are both negative. In problem number 5, the signs are both positive. And of course, problem number 8, signs are same positive too. So you didn't have any 0 pairs when the signs were the same. But when the signs were opposite of one another, like in problem numbers 1, 4, 6, and 7, we created some 0 pairs. Okay, so now let's compare how those 0 pairs related when they were opposite signs. Because sometimes we got a positive answer, like in problem number 7, we got a +7. How does that compare to like problem number 1? You had a -7 and a +2, and you got a negative answer. Do you see the pattern yet? Alright, I'm going to tell you the pattern. This is going to be the rules for adding integers. Because honestly, you can't make little plus and minus signs for pretty large numbers. Let's take a look. So I've turned the page. Look at the problem there. 100 plus -37. Can you imagine drawing 100 little plus signs and 37 little negative signs? No. So the pattern is, if the signs are the same, you're always going to add the numbers together. If the signs are different, you're always going to subtract. That's what happened in the previous page. Whenever we had the signs the same, we just added the number of signs together. But whichever number is bigger will determine the sign of our final answer. 100 is bigger than 37. So we expect that our answer is going to be positive. It's like having $100 in the bank. If you took out 37, Aren't you still going to have positive dollars in your bank account? Well, what would happen if it was reversed? If you had negative $100 in your bank account and you added positive $37, you'd still be in the hole, wouldn't you? The same concept applies here. So whichever number is bigger, that's the one that wins, like the sign war, if you think of it that way. So here's a little naughty mnemonic device to help you remember this rules. It's SOB, son of a brainiac. Yeah, you can remember however you want, but we're going to use the letters SOB. They stand for same signs add, opposite signs subtract, bigger sign wins. Whenever you see the word combine or use the word combine or you see the addition, then I would like for you to write this and say this out loud as you write it. Same signs add. Kind of looks like a snake with a little rattle tail on there, and it has the addition sign. Opposite sign subtract. Bigger sign wins. Everybody always forgets the bigger sign wins, so I make a big deal about that. Now, when you're sitting there, and I wish if I could turn around and film myself, you could actually draw an S in front of you and put your fingers together like a plus sign and say, same signs add. And then draw a circle above your head and say, opposite signs subtract, and draw a little subtraction sign with your finger. And bigger sign wins, and throw your hands up in the air. Now you might think that's silly, but we remember things with muscle memory. Let me see if there's a way that I can actually turn the camera on myself. I'll do this just for you today. Well, I looked and looked. I couldn't find a way to do it. It would only let me take snapshots of myself, not really a video. But sometime if you want to come see me, I can show you what I'm talking about. So that's one way to help you remember those rules. Same signs add, opposite signs subtract, bigger sign wins. I would recommend saying that over and over and over again until you got that straight. Write it down on your paper several times, maybe 3 or 4 times, until you can write down the rules without even looking at it. Or write SOB and put the little plus sign, the minus sign, and the bigger sign wins, so to help you remember. Now, if that doesn't help you, some people can remember things by songs. Maybe you remember lyrics to songs very well. So this is the tune of Row, Row, Row Your Boat. And again, I will do this for you just this one time because I cannot sing it all. It goes like this. Here we go. Same signs add and keep, different signs subtract. Keep the sign of the bigger number, then you'll be exact. Okay, I'm not singing it again for you, but if you would like to try practicing the song to help you remember how to add integers. Adding integers or combining integers is probably the most frequent operation of integers that you're going to do all through algebra. You need to get really good at this. So I've given you some guided practice problems to do, and I want you to go ahead and solve as many as you can right now, and then we'll go over the answers. Now, if you were stuck already, then let's at least do a couple of them, and then you can push pause and do the next 3 on your own. So the first problem reads 6 plus 48. Well, I gave you a real easy one off the bat. Of course we know it's 6 plus 48. We've done this before, and it doesn't even have any signs. Now you might be tempted to put your 48 on top, and that's fine. I would too. 6 plus 48, those are the same signs, so what are we going to do? We're going to add these two numbers together. Well, 6 and 8, what is that, 14, carry the 1, so 54. And the bigger sign wins. 48's bigger, so our answer stays positive, is 54. You've done that type of problem before. Alright, let's take a look at the next problem. 90 plus negative 14. Are those same signs or opposite signs? Well, 90 is positive. Remember, if we don't see a sign in front of it, its sign is positive. So we have a positive 90 and a negative 14 that you're trying to combine together. Are those same or opposite? Well, they're opposite. So opposite signs subtract, right? So we have to take 90 minus 14. Regardless of the fact that this is an addition problem, we do subtract. Alright, 90, I need to borrow 1 from the 9, make it 10, equals 6. 8 minus 1 is 7. So I get 76, but I'm not done. Don't forget, you got same signs add, opposite sign subtract, bigger sign wins. So which number is bigger, the 90 or the 14? The 90 is bigger, and what's its sign? Positive. So therefore, our 76 is positive. That's your final answer. The next problem, we have negative 57 plus negative 89. Are those same signs and then we have to add, or the opposite signs and we have to subtract? Well, they're both negative, therefore they're the same. So we have to add those two numbers together. Add the 57 and the 89. Well, 7 plus 9 is 16, carry my 1. And 6 plus 8 is 14. Right? Checking my own work here just a second. Yeah, 14. Alright, and which number is bigger? Well, it doesn't really matter. They're both negative, so there's no choice. The answer has to be negative, but 89 is bigger than 57, and it's negative. Therefore, our final answer has to be negative. Bigger sign wins. Bigger sign wins. Alright, so if you needed that additional help, then go ahead and push pause and finish the next 3 problems. Push play when you're ready. Otherwise, you can keep watching to check your answers. Alright, the next problem, you have 73 plus negative 55. Those are opposite signs, so we have to subtract. Oops. Now when you do your subtraction, you'll always write your bigger number on top, no matter if it comes first or second. 73 is bigger than 55, so I'm going to put it on top, and I have to subtract. So, I get a 6, I had to borrow one. I get 8, 6 minus 5 is 18, and the bigger sign wins. Well, 73 is bigger than 55, so my answer stays positive. It's positive 18. The next problem, I have 72 plus negative 92. Those are opposite signs, so again I have to subtract. And when I subtract, I write my bigger number first over 72, and I need to subtract. 2 minus 2 is 0. 9 minus 7 is 2. And the bigger sign, which is the 92 is bigger than 72, is negative, so that one wins. And the last problem, negative 71 plus 47. Again, we have opposite signs, so we have to subtract. Let's put the bigger number on top. I have to subtract. I need to borrow on this one. 11 minus 7 is 4, right? Yeah. 6 minus 4 is 2. And 71's bigger and it's negative, therefore my answer is negative. Negative 24. Okay. So you're going to have some of these problems on your guided practice here after we finish all the operations. Alright, your next operation is subtracting of integers. Now honestly, you're never ever going to subtract integers. But you're asking yourself, well, then why am I learning? Subtracting of integers is something that maybe credit card companies think of when, well, let's just go over the example and then it'll help you understand. If you make a charge on a credit card of $20, you are in debt, negative 20. So the credit card company thinks of you as negative $20. That's your debt. If you return an item, you're giving it back, then you get a credit, right? A positive number. You think of it as I'm putting $10 in the bank. But a credit card company would always ask yourself, well, if they're negative $20 and I want to take back or take away $10 of their debt, a negative 10, do you see what it is? A minus a debt, it's like taking it away. They want to take away negative dollars. But you would think of it as the question, the same story, you would ask yourself, well, what's negative 20 plus 10? Little confusing? Yeah, I know. And that's why everybody's like, I don't understand subtraction of integers. Just remember you're always going to change subtraction into an addition problem. So to help you remember the steps on this is simply keep, change, change. I think that's what keep, change, change. Once you keep, change the problem, you are actually going to turn any subtraction problem into an addition problem. So because you're going to turn it into an addition problem, then you're going to use those rules of additions, that SOB, to actually solve your problem. So let me show you some examples of what I mean. Get my pen ready here for you. So in the first example, you have -5 minus 7. That's the same thing as saying -5 minus +7. So what you're going to do is always keep your first number. So I'm going to keep that -5. I'm going to change my problem to an addition problem. Change. And then I'm going to change the sign of the second number. Now that second number on this problem is a +7. So that means I have to make this a -7. This first example is actually one that people miss all the time. They'll simply do this. Oh, -5. And they'll do minus, and they'll do this for some reason, do a plus. And that's not changing it. It was already positive. So be careful you don't make that same mistake. Alright, now that we have an addition problem, here's our addition, now we use those rules of SOB. Are the signs the same or are they opposite? Well, they're the same, a -5 and a -7. So what do we have to do if they're the same? Same signs add. Okay, so 5 plus 7 is 12, and the bigger sign wins. 7's bigger than 5 and it's negative. So our final answer is -12. So the original problem, -5 minus 7, it'd be like saying, oh, I have -$5 in the bank and I want to take away a credit of $7. What does that mean? Putting it in real life terms might be a little difficult to understand. Let's try the next problem, example 2. 2 minus 8. Now it sounds simple when we say it, but if we had +2 and we take away 8, think of your bank account. If I have $2 in the bank and I take out $8, ooh, that's not good, right? I'm going to be in overdraft. So 2, you keep the first number, you change it to addition, and you change the sign of the second number. So we made it a -8 instead. Now what do we have? We have a +2 and a -8 that we're trying to combine together. Are those same signs or opposite signs? They're opposite, so we have to subtract. 8 minus 2 is 6, and the bigger sign wins. So it's a -6. So keep the rule. Keep, change, change, SOB. Keep, change, change, SOB. Let's try example 3. You have a -4, we're going to keep that. Minus, so we're going to change it. Keep, change, change. Change it to addition. Now the problem reads -4 plus +8. Are those same signs or opposite signs? They're opposite, so we're going to subtract. Always take your larger number and subtract the smaller, so 8 minus 4 is 4, and the bigger sign wins. Well, which one's bigger? Make sure you used your changed numbers here. 8's bigger than 4, and you change it to a positive, so it's a +4. Your final example, you have 2 minus -7. The operation is subtraction, so we have to change it to addition. We keep, change, change. Oops, there we go, change. It's supposed to be a plus. Alright, keep, change, change. Now do we have same signs or opposite signs? Well, you have this 2 here. What's its sign? Remember, if you don't see it, it's positive. +2 and a +7. Those look like the same signs to me. Same signs add, so 2 plus 7 is 9. And they're both positive, so it has to stay a +9. Alright. Alright, I have 3 guided practice problems for you. I want you to try to solve them on your own. Problem number 3, I even want to put your answer into the grid. Remember what we said before about the grids? We never put spaces in the middle of an answer, and you always write your answer from left to right. So I want you to go ahead and try all 3 problems the best you can. Push pause while you're doing it, and then push play when you're ready to check. Alright, ready to check? Problem number 1, you have 12 minus negative 5. So let's rewrite that as 12 plus positive 5, because we keep change. Well, we know what 12 plus 5, that is pretty easy. That's 17. That's your final answer. So whenever you see 2 negatives side by side, some people have learned, and they'll start doing this, they'll circle it here, I'm trying to circle it for you, my pen's not going that fine, let me zoom in for myself. They'll circle the 2 negative signs, and they'll just write it as one big positive. You can do that with problem number 2 as well. It's kind of, they keep change all at once. We've got 2 negatives, so we put it together and make a plus sign. So now we have a negative 10 and a positive 14. Those are opposite signs, so we subtract. You know, the other way you could write this, negative 10 plus positive 14. You could have done it that way. That's fine too. Those are opposite signs, so we have to subtract. 14 minus 10 is 4. And the bigger sign is positive. The 14 is bigger than 10, so your answer is positive 4. In problem number 3, you do not have 2 side-by-side negatives. So we can't just circle them together and change it to a big plus sign. What would it be like then? Negative 18. So we keep, change, negative 23. You could have done it on the problem itself. Keep the negative 18, make this a positive, and then change the 23 to a negative. It works the same way. So now do we have same signs or opposite signs? Negative 18 and negative 23, those are the same signs. So we have to add. Well, what's 23 and 18? Maybe you can do these in your head, which would be great if you can. I can't. 11 is 4. So I get a 41, and then don't forget bigger sign wins. 23 is bigger and it's negative, so the answer is negative 41. To put it in your grid, let's see how you did with that. I gotta zoom back for myself. So we want to put in our box negative 41 for our answer. Notice I didn't do this, put a bunch of zeros in here or something like that. It's okay to have spaces in the columns. One symbol, when I say spaces, after our answer, not in between our answer. So make sure you do not do this, negative there, and write 41 down here. You'll get the answer wrong because the computer's looking for gaps or spaces. So let me do this, negative 41. Then once I write my answer across the top, down each column I have to color in the bubble that represents. So I'd color in the negative sign, the 4, and the 1. And that would be my answer, negative 41. Alright, off to multiplying and dividing integers. We're going to group this together, but because actually multiplying and dividing has the exact same rules. Doesn't matter if you're multiplying or dividing or you use these rules. Now I'm going to show you 4 different methods, and you choose whichever method you like the best that you think you can remember every single time. Alright. Some people know the rules for multiplying integers and they apply them to addition and subtraction, maybe because they learned them in the past and that's the only thing that they can remember. So we always have to really unteach that because you use those for adding and subtracting by accident. You need to remember adding and subtracting, adding or combining. You have to use SOB, and then subtraction, keep, change, SOB. Alright, for multiplying and dividing integers, I'm going to show you each of the 4 methods that I know. Maybe some people out there have other memorization techniques to help you remember how to multiply and divide integers. I want to show you these 4 because it depends on what kind of learner you are. The first method is even and odds. Some of you might recognize patterns. There is an advantage to learning this method over the other ones, and that is if you have a long strand of multiplication and division in a problem where you have lots of multiplication and division, the even and odd rule, you can just solve the problem just as if no negative signs are there at all, and all you're doing is counting up the negative signs to get your final answer. You don't have to do just 2 little problems at a time. Okay. So what do I mean by that? Let's look at a couple of examples. In example 1, you see -2. What's that dot mean again? Do you remember from the previous lesson? It means multiply. -2 times 9 divided by -3. Alright, let's pretend for just a second that there were no negative signs on those numbers. What's 2 times 9? 18. And what if we took 18 and we divided by 3? You get 6. Sorry, I don't mean to be yawning there. You get 6, right? So the answer is 6 there. But now how do we know if our answer is going to be positive or negative? Well, count up how many negative signs you see. Let me see if it's letting me write yet. How many negative signs do I see? I see 1. Oops. I was trying to circle it. I see 1 negative sign, 2 negative signs. So I see 2 negatives. Is the number 2 odd or even? Well, I guess first of all I need to make sure you know the difference between odd and even numbers. Our even numbers, that's the cheerleading numbers, 2, 4, 6, 8. Don't forget 0. 0, 2, 4, 6, 8. So if there's 0, 2, 4, 6, or 8 negative signs, and all we're looking at is the negative signs, then our answer will always be positive. Otherwise, all those other numbers, 1, 3, 5, 7, or 9, our answer will always be negative. So there's 2 negative signs, so our answer is positive because it's even. So that's why they got the answer of positive 6. Let's take a look at the next example. 4. You see a parenthesis, -2. Remember the operation there? Sometimes we use parentheses to mean multiplication. That's the case here. And the reason why it is because we only have one term. There's only one constant inside that parentheses. So that's how we know that it means multiplication. I'm kind of getting ahead of myself to one of the lessons that you'll have tomorrow or the next day. This is an example when we have more than one term. See, 1 term, 2 terms inside the parentheses. That does not mean the multiplication. Now the 2 right beside it does mean 2 times the quantity 2 plus 3. Okay, so I don't mean to confuse you with all that, but I just wanted to point it out. Sorry. So we have 4 times -2 times -1 times 3 divided by -6. Yeah, in algebra, we're going to not see this division symbol much longer. Now they're just going to use the fraction bar to mean division. Alright, so we have to work our way from left to right. 4 times 2 is 8, and we multiply that 8 times the 1, and you still get 8, right? So then we take that 8, we multiply it by 3, and we get 24. And then we divide it by 6. Well, what's 24 divided by 6 is 4. So you just do the multiplication division as you see it, from left to right, just as if those negative signs weren't there. Now we're going to go back and look for those negative signs. How many negative signs do you see? I see 1, 2, 3 of them. Is 3 even or odd? Remember again, 3 is odd, so our final answer has to be negative. So your final answer is -4. Yeah, I know it's given to you right there in the example. Alright, here's a guided practice problem. I want you to try it. I made the multiplication super simple. Everybody remember what 1 times 1 is? It's just 1. So I just want you to figure out, okay, if it's 1 times 1 times 1 times 1, what are you going to get for your answer? You try it. If you need to push pause to think about it, go ahead and push pause. Push play when you're ready to check your answer. Okay, 1 times 1 times 1, no matter how many times you multiply 1 by itself, the answer is always going to be 1. Alright, how many negative signs do you see? I see 1, 2, 3 of them. 3 is an odd number, so the final answer is -1. Okay, so method 1, even and odds. You can look at even and odds of multiplication and division problems. Method 2 is same and opposite. Kind of has the same approach to even and odds. In this method, you just remember that if the signs are the same, your answer is going to be positive. For example, a positive times a positive equals a positive, and a negative times a negative equals a positive. And if the signs are opposites, either a positive times a negative or a negative times a positive, then your answer will always be negative. So generally in most of your mathematics that you're going to be working with in algebra, you're only going to be looking at 2 numbers at a time. So this is pretty easy to remember too, or for some people. So looking at the first example there, I have a -56 and a -7, or divided by -7. 56 divided by 7 is 8. And notice the signs are the same. Same, positive. So can you do the guided practice? Negative and a positive, so we expect our answer to be their opposite, so negative, and 3 times 10 is 30. Got it? So that's just another way. Methods 3 and 4 are for people like myself, actually. I like pictures. Pictures help me remember a lot of things. I like to doodle on my papers and stuff. By the way, if you are a doodler and you're in class, at least doodle about what it is you're learning. I like making pictures to help me remember things, because I can remember pictures or things I see much longer than I can remember phrases and things. And for some of you who are like me, you might like these approaches too. So method 3 is the sine triangle, and it's very simple. A sine triangle, or another way to think of it, as the sine teepee. So you make yourself a little teepee to help you remember, oh yeah, this is for multiplication, that's why I say teepee. And you put a little plus sign up here and 2 minus signs. And the way this works is you get to actually, and it's also for those of you who like to move around a lot, like you need to move your hands while you're doing your math, this is the method for you. So I'm going to have to, because you can't see my fingers, so what I'm going to use is a purple marker to show where I would put my fingers. In the first example, I have 6 divided by -3. So what you will do is take your 6 and divide it by 3 as you normally would, just as if the signs were there. 6 divided by 3 is 2, so we know the answer is going to be 2 of some sort. But if you didn't know what sign your answer was going to be, what you do on this triangle is you cover up the signs that you see. I see a +6, so I'm going to use my finger and I would cover up the positive sign, and a -3, so I just cover up one of the negative signs. It doesn't matter which one. Whatever I'm left over with tells me my answer, so the answer is -2. Let's try it with the guided practice. You have a -3 and a -7. Well, 3 times 7 is 21, so we know it's going to be 21 something, but we don't know if it's going to be a positive or a -21. Alright, use your finger on the triangle and cover up the signs in the problem. So our first factor was negative, so we'll cover up a negative sign, and our second factor is also a negative. So we're left with a positive, and that means our final answer is +21. Pretty simple. If you're actually doing this with your fingers, some people really like this, and it's real easy to remember this rule if you just simply draw the triangle at the top of your page. Now, a great testing technique, just a second, sorry. Okay, if you can't remember to draw the triangle or how to draw the triangle, also the triangle does assume that you know if you have a positive and a positive, your answer would always be a positive, because you can't really cover it up. But another method that I saw somebody using just recently, so I added this too here, is the happy positive face and the sad negative face. And I think people can remember these. All you have to do is draw a picture of a happy face and a sad face, and you see the happy face has 2 eyes and 2 eyebrows, and you gotta two positives that are the same, two negatives the same, so you got a happy little face, and a happy little face always means you get a positive answer. But look at the other two faces, poor guys. It kind of looks like they have black eyes. You have either a negative or a positive and a negative, or a negative and positive. In both cases, it looks like they just got hit in the face. So of course they're going to be sad, and your answer is always going to be negative if the signs are opposite. So it kind of combines that whole opposite or same positive opposite in method 2, but puts a little picture to it. So I've started seeing people using the sad and happy faces before. When you're taking your test, you will get some scrap paper, whether it's the unit test for this lesson, or if it's the TABE test or the ECA. You'll get scrap paper, and a great testing procedure, especially those of you who have testing anxiety, and you're worried about forgetting any of the rules to your integers, you can always just draw these little pictures before you even start testing. In fact, when they're giving the directions or after they've handed out the scrap paper, you can't take notes with you to a test, but once you get your scrap paper during a test session, you can write all over anything you want. Now, it's got to come from your own head, so if you're chanting the rules in your head several times, you can take a few minutes and just write down these little pictures to help you remember your rules before the test even begins, before time even starts. And that, I've found, really helps with test anxiety, because those of you sometimes take a test and all of a sudden your mind just goes completely blank, because here you are trying to remember, okay, it has the same signs ahead, opposite signs subtract. You're chanting all these things in your head, and then when you go to take the test, the first problem you look at is not an integer problem. So you get confused, and your mind just starts going blank, and you forget what you're doing. It happens to a lot of people, and this is just one way to overcome that test anxiety, is to draw these little things on your test scrap paper before you even look at the first problem. Then you can forget about it. If you forget the integer rules, oh well, you have that picture on your paper that you can refer to later when it's time to remember. Alright, I would like for you to go to your guided practice problems, do all the problems on the page. Notice that they're going to be mixed up. And this is key. On most standardized tests, they don't just put all the addition problems together in one spot and all the subtraction problems in it. They've got them mixed up. So you have to get your rules straight in your head and use the right rules for the right operation. Don't become too impulsive. Okay? So try the guided practice and then check your work with the self-check and correct. Good luck.